Quick, graph y equals a sine of the quantity 3 times x by hand 2 different ways. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed, and press pause as needed anytime during this video. The first way is with the sine dance. Recall what the graph y equals sine of x looks like, one period of the wave, and notice the 5 key points of interest. These key points and all points are affected by the parameters in the equation. The coefficient of x, b equals 3, inside the parentheses, affects the width of the period inversely. The horizontal dilation factor, you may recall, is 1 divided by b, or the reciprocal of whatever b is, which in this case, the reciprocal of 3 is 1/3. The period of the sine function is 2 pi. For y equals the sine of the quantity 3 times x, the period is going to be 1/3 of that 2 pi, which is 2 pi over 3. Pause is needed. So the period is 2 pi over 3. We need to use a different scale along the x-axis. We're going to suggest marking off every pi over 6 and from at least negative 2 pi over 3 to positive 2 pi over 3. Pause to do that. So there's our negative 2 pi over 3 to positive 2 pi over 3. We marked off every pi over 6. The initial point is normally at the origin. This point is unaffected by that 3, so we're going to plot the origin to start with also 0, 0. The end of the period is normally at 2 pi 0. However, for this graph, the end of the period will be a period later, 2 pi over 3, 0. Halfway between the initial and the ending point of a period is a point of inflection. So that's going to happen here halfway, and you can see that that's going to be at pi over 3, 0. Halfway between the first 2 points of inflection is a maximum at pi over 2, 1. So for our purposes, that's going to be at pi over 6, 1, halfway between these two. And halfway between the second and third points of inflection is going to be a minimum at negative 1, and the x-coordinate will be pi over 2, negative 1. Pause is needed. Connect the points as a sine wave, concave down, concave up. And we can plot one more period to the left by going back a full period, 2 pi over 3, from each of the key points. And connect those as a sine wave. A generalization, the period of a sine wave is 2 pi normally. Y equals the sine of x, the parent function. You can see that from here to here, it goes one complete wave and starts to repeat. But what about the period of an equation of the form y equals the sine of the quantity some number b times x? Since b affects the period inversely, the normal period is multiplied by the reciprocal of b, which is 1 divided by b. That is, the period of y equals the sine of the quantity b times x is 1 over b times 2 pi, and we can write that as a single fraction as 2 pi divided by b. So the period of y equals the sine of the quantity b times x is 2 pi over b. This is a big deal. You probably should write it down and remember it. Pause is needed. So generalize, here's our generalization here. We should like you to try these 3 here. Pause to answer these 3 questions. Resume when you're ready. So for the sine of the quantity 3 times x, the period is going to be 2 pi divided by that 3. So 2 pi over 3. If b is 4, it's going to be 2 pi divided by 4, which simplifies to pi over 2. And here, 2 pi divided by 1/3, remember, dividing by 1/3 is equivalent to multiplying by its reciprocal 3, so the period is 6 pi. Pause is needed. Resume when you're ready. Second way to graph this is by table. And we'll use the axes values, complete the table, pause to do so. Those are our unit circle values on the axes. Create a second table. And this, again, coefficient of x3 inside the parentheses affects the width or the period of the graph inversely. So we're going to multiply each x value by the reciprocal of 3, which is 1/3. But to do that, we're going to have to change the units along the horizontal axis because of that 1/3. And so we're going to mark off every pi over 6 and have it go from negative pi to pi. Pause to do that. So multiplying each x value by 1/3, 0 times 1/3 is 0. We're keeping the y values the same. They are not affected by this 3. So plot the origin. Pi over 2 times 1/3 is pi over 6, comma 1. Plot that point. Pi times 1/3 is pi over 3, comma 0. Plot that. 3 pi over 2 times 1/3 is pi over 2, comma negative 1. And 2 pi times 1/3 is 2 pi over 3, or 2/3 pi, comma 0. Pause is needed. Connect the points as a sine wave, frown, and then a smile. And let's plot another one to the left by going back a period, 2 pi over 3, for each point, but especially the 5 key points of interest. And we'll complete the sine wave. And compare that to the parent function. Pause is needed. Now you try one. Graph y equals the sine of the quantity 4 times x, and you can use either method or both for the practice. Also, tell us what is the period. Pause is needed. So it turns out the period is 2 pi divided by 4, which simplifies the pi over 2, and you can see that in the graph here. Notice that the axes are not drawn to scale.